can you listen up? Listen. No, I'll explain now. Ignore. Right. So, just before, Amna, listen please. Just before we have a look at the exams, there's a question from that extra page I gave you a couple of weeks ago. And actually this is quite relevant because, was it yesterday that we were using this flowchart? Yes. Yeah. So we're just going to do a question from this before we go back to the exam papers, alright? But we'll have a look at the exam papers in a second. Alright, so it's 2f from that page I gave you. You're given the function y equals minus log x power 16 minus 2x squared minus 16x minus 2. And the question was, find the stationary points and determine the nature of the stationary points. So what will I need to do first to get the stationary points here? Yeah, derivative. Well, actually, before I do that, what should I do? Bring the 16 down, Minus 16 log x minus 2x squared minus 16x minus 2. By the way, which values of x can I not use? 0. Yeah. Minus is actually alright for this one. It just can't be using 0. Yeah. Alright, derivative. So, what do we get here when we differentiate? First,
minus 16 over x.
Yeah, next, minus 4x minus 16 equals 0. Did you say plus c?
Plus c, yeah.
Oh no.
No.
What do you? No. What are you thinking? Yeah. Right, next. Next. What should I do? Yeah, so what should I do to simplify? Multiply by x, so minus 16 minus 4x squared minus 16x equals 0. We shall divide by minus 4, yeah? 4 plus x squared plus 4x equals 0. Quadratic, yep. X squared plus 4x plus 4 equals 0. Plus 2 plus 2? Yeah. Right, so x equals minus 2. I really should put this back in to get the y, but we'll skip that part just for the moment. Because the next part is we want to know what type of stationary point it is. So what is the next step now? Second derivative, yeah. Now, it might be helpful just to remember that this here is like 16x minus 1. So the second derivative here will be 16 over x squared minus 4. Yeah? If I put in minus 2, let's see what I'll get. That's 16 over 4 minus 4, which equals 0. Now that's a problem. Yeah, well, it's not informative here. So that flow chart I gave you, let's have a look at what it says to do. Mubarak, come on, hurry up. Yes? No, this is the page I gave, do you remember this extra page I gave like 2 weeks ago? Yeah.
Why did you try minus
2? No, put in minus 2, you get 0 here.
X is minus 2, we found x. Oh,
Yeah. Right, so if we look at the flow chart, first we differentiate and got 0. Then we differentiate and got 0 again. So the next thing to do? Differentiate again. So what will that be? That'll be minus 32 over x cubed. Now if I put in minus 2, I'll get a minus over a minus. So whatever it is, it'll be a positive. And according to what I gave you, if you go 0, 0, and 0, 0, and positive, it looks like this. Minus 2. So it goes like that. Yeah?
Is this worksheet on Moodle? In case I can't find it.
I'll print you out one. It's not on Moodle. Ryzen and saddle. Yeah. What is the other way to do this without having to use the third derivative? Yeah, by getting points. But that's longer. Yeah. Neighbouring points.
If they ask us to find the saddle point, then it will be different.
They won't ask you to do that. They never. They only ask you to determine the nature of the stationary point. Saddle point isn't the word they usually use in the exam. You've probably noticed, but the word they use is inflection. Yeah. Yeah. It is inflection because what's the name of the shape here on the left? What's this part called? Concave. And then here? Convex, yeah. And this is inflection point. And it's also not only is it an inflection point, but it's also stationary here. Okie dokie, yes?
According to the graph, the first derivative of the equation is negative, but y, which is
I thought my first derivative was 0.
is negative 2.
No, that's the x is negative 2. But if you sub that back into the derivative, you get 0. It's the value after you put the x in, not the x value. Yeah. Okay? Yeah?
What's the y-axis?
Oh, we haven't calculated it.
We don't.
You can't, you should, but that's just putting the number in at the beginning. It'll be a decimal because of the log. Yeah? Is that one okay? There's more on this for you to practice anyway.
When you sub and get the y, then that's the saddle. That's the inflection point, right?
If you, I didn't bother calculating it, but if you sub in the x minus 2 into the original, you get the y.
Yeah.
Yeah.
That's the point.
That's the point, yeah.
Substitute negative 2 or 0.
Minus 2 into the original. Well, look, there's the x minus 2.
No, the y-axis.
The y. So, huh?
The y-axis. The y-intercept.
Yeah. I don't care about that. I wanted to know this.
Oh.
Y-intercept minus 2.
Yeah. Yeah, so my graph is totally off. I should have had it lower, is it? Yeah, okay, fine. So it's down here then.
Yeah.
Okay. Because the y was minus 2, was it?
Well, the y-intercept.
No, hang on. We just said we can't make x 0. Didn't we?
Yeah, that's all.
Yeah, so it has no y-intercept. So it breaks at the axis. So it probably shoots up like this. Yeah. Yeah? Yeah?
Do they like if you graphed it like that in the beginning, would they take marks away because they know that there's no?
Well, in the exam they'd ask you for. No, they wouldn't. They'd only give you. They wouldn't put log in it. The problem arises because of the log. They wouldn't do that in the exam. Yes? Question? No. Anyways, this is not so common in the exam, but I thought a worksheet would be helpful on it. So we can go back to the exams now. So what do we want to have a look at next? Which version, which question? Yeah, which version? Yeah? Yeah, give me a version and a question and we'll do it.
Is it a lot?
Yes, it is. I did it this morning. Which version? Which question? Huh? Everybody looks sleepy. It was the English exam.
Yeah.
Took it out. What one did you have?
Listening and reading.
Listening's boring.
Yeah.
That's the one exam I hate invigilating because I have to listen to it. Garbage. Boring. And what else?
Reading. That's boring.
Was it an interesting topic?
No.
What was it?
Completely boring.
What was it?
The first one was so annoying.
What was it?
Design.
Beauty and design. Beauty and environmental energy
energy
plans.
The third one was interesting.
What was that one?
It was like language
Language
diversity and
diversity.
extinction.
Oh, okay, yeah, that's interesting.
There's only three.
Why do native speakers need to say the exam for the English?
Yeah. Anyways, doesn't matter. Yeah.
Can we do 2005, 2006?
It's over a decade now.
Were you even born then? Like,
He was 6 years old.
what question is it? What's it about?
Trade.
Trig. Is it a hard one? Yeah, we can do it.
12 sine squared.
Okay, hang on. Right. 1516 version.
No. 2005, 2006.
Oh, yeah, sorry. Of course. Oh, 506.
No, 67.
67, okay. 67 version.
B.
Tray question.
C and D.
Which number, man?
4.
4, C, and D.
I think he does this on purpose.
I know he does this on purpose. Can, if you like, you can open this, but Amjad will. No, hang on. Amjad will read it. So, what did they ask for in part C? Go for it.
So,
Yep.
sine squared.
12
Then sine squared.
sine squared.
Theta.
Yeah,
Plus 5 cosine theta.
yeah.
Equal 10.
Equal 10.
Yeah.
And theta between 0 and 360.
Yes.
Yeah. Okay. Yeah, we. Not as bad as it looks. I know it looks pretty bad, but any ideas on what to do first here? We did this in class a long time ago.
Switch the sine squared.
Switch the sine squared to cos squared. So it's 12
1 minus.
1 minus cos squared theta plus 5 cos theta minus 10 equals 0. Yeah. That's 12 minus 12 cos squared theta plus 5 cos theta minus 10 equals 0. That's 12 cos squared theta minus 5 cos theta minus 2 equals 0. I think this quadratic will be okay to factorize. But it has to be 2 and 1, that's for sure.
So what happens to the negative quantity?
I took everything to the right. What is it?
It's 2 over 3 and
2 over 3.
Yeah. I did this stuff.
2 over 3.
3 cosine, yeah.
3 cos.
Yeah. So this one has to be 4 plus. So you get two answers here. Cos theta equals minus a quarter, which is okay. And cos theta equals 2 over 3, which is also okay. Yeah, go ahead there. What's cos inverse minus a quarter? In degrees.
It's 104.47.
Yeah, now the second answer for cos is 360 minus this. If I do three significant figures, that's 104, and 360 minus this, what's that? 360, 262, 256? Is that right? That's right, isn't it?
255.5.
Yeah, so 256 then. And here, what's cos inverse 2 over 3?
48.18.
48.2 then, yeah? Yeah. And then 360 minus that is 311.8, so 312.
Sir, is it okay to round up this one?
Well, they insist that the answer is three significant figures. But you never lose marks for putting in more. This is the minimum number of digits. So if you said 311.8, that's fine too. Only matters when the question specifies a particular rounding. Yeah. Now it's really good to check that you got the right answer here, so I'll just let you write that down. I doubt myself sometimes, that's all. Now, Amjad, I don't think the trig, in fact, I'd be very, very, very surprised if they made the trig equation this hard in your exam. Because the new exam writer, they keep the trig equations linear. Now, sometimes you might get a trig equation like this. They might say something like sine squared theta equals 2 over 3. So it's kind of a quadratic, but like the simplest kind. Because it's just a square root with a plus and a minus.
How would you solve that?
Square root.
Inverses.
Yeah.
Let's check the answer. Whoa. Okay.
Where it's from?
I'm checking. 12 sine, what's my first one? I'll check. 104 plus 5 cos. Now I should get here 10. Yeah. The second answer?
256.
256 and 256. 10. What's the next one did we get?
48.2.
That's even better. And the last one was 312. 312. Yep. Ah, yeah. Fine. Rounding.
In the 14, 15, 5, are the ones the final or that?
Which one?
In the 14, 15.
14, 15 exam.
They're saying, is it the final or end of semester? I can't tell.
It's
Because
end of semester 1 exam.
Question, sir.
Yeah.
So why did you find 4? Because there's no 2 in front of theta. Why did you find 4's answer?
Because it's quadratic.
Quadratic.
So the square doubles the number of answers because there's 2 linears. Like this linear, how many solutions if I said solve this equal to 0?
2.
2. And this one? 2. So 4.
There's 40.
Oh yeah, of course. Is it trig?
No, it's a graph.
A trig graph.
Find the formula.
Again, I'd be very shocked if they asked it, but it's good to practice. Can I scroll down? Yes, come up with the phone. I want to see the graph. I'm scrolling down. Right. Oh, okay. Right, this point here is 2, isn't it?
Yeah.
This point here is pi, and it comes down to pi, and then that max is 4 pi,
And 8.
and this is an 8, so it goes, the max is at the 4 pi, so it hits it up there, and then, is there a number at the end?
It's 8 bar, I think.
No, there's nothing there, that's just theta.
No, this one.
I mean, but they don't tell you that.
Yeah.
This is everything, yeah? So hang on, that comes down to here and goes back up. And what, this is theta and this is y. And do they give you the equation or they ask you to find, no, they don't tell you if it's sine or cos. It says find a formula. Okay, let's do that one now. Okay, this is a good question on the graphs. It's tricky. It's definitely a difficult one. And in fact, there's more than one answer because they just want a formula that makes this graph. So if you look at this graph, does it look more like a sine or more like a cos? Yeah,
It's a sign.
both. You could have used both. But I think
It could be sine and just move to the right.
I'm kind of looking at this as a sine that's been moved to the right. So I feel like it'd be easiest to imagine it as a sine. Yeah. So, because what I'm going to do, I'm going to work backwards. So if we think about the process backwards, what was the last step in making the graph?
Both up.
No, I mean like when we did the graph, what's the last thing we do? So first you make the table, and then after the table, what do you do on your graph? No?
Find y.
We make a box. The last thing we do is copying and pasting the box. So we are going backwards. We have to put in a box where we can fit sine inside the box. Now, 2 and 8, the distance there is 6. So to me, the middle of the box should be at 5. Because that's in the middle between 2 and 8. Yeah? Now, I could look here. I think if I look here, go down, go across here at 2. Sine goes up, down, so this would continue up to here. Oh, well, you get the idea. It's put inside this box here. So what happened at the end was you had a sine graph drawn in. OMG. Sorry. Yeah, I just realized I messed that up. Let me just put in dot, 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 dot. And it's here I should have done it, isn't it? Yeah. And this, so not 5 but 4. Yeah. And then this goes down, and then this went up, down, and it continued back up to the middle. Okay. And then down, and then down. Okay, so let us try and work backwards. So you know you had your table start, end, min, and max. Yeah? Anyways, if it's supposed to be sine, I can fill out what the first row was. It was 0, 2 pi, minus 1, 1. Yes? Then what you did was you considered the A, then you considered the B, then you considered the C, and then you considered the D. So let's write our equation down. It's y equals A sine B x. Do I usually write plus or minus here? You can do either. We'll do plus. Plus D. Okay. Right, if we look at this box goes from 0 to 8. Yeah? And which letter affects that? The A does. Yeah? So, it must have meant after I considered the A, I went from... Now, what number would I have to have the A so I could possibly get a box this big? How big is this box? It's 8 units. But usually how big is the box? If you did 2 units. So what do we think the A is?
4.
It must have been 4. The A must have been 4. Now you realise that's obviously not finished because it's not minus 4 to 4, it's 0 to 8. Okay, but we think we have the A. Amjad, you asked me for this. Would you look at it, please? So, let's go on to the B next. What's the period here? Well, it's not quite clear in this box, but if you look here, here we start at pi, and then we go up and back down. Now, but we don't know that. So, look here. If I start at pi and go half a period, that's pi up to... that's 4 pi. So how big is this here?
2 pi.
No, this is 3 pi. 3 pi. And half a period is 3 pi. So the full period is 6 pi. So what does that make the B? How much bigger is the period if it went from 2 pi to 6 pi? 3 times bigger. So the B must have been 3. So that will change it from here 0 to 6 pi minus 4 to 4. Now what does the C do?
C moves it?
Moves it.
Yeah, to the right.
We should start at 0. Where do we start now?
4.
No, the X.
Pi.
No, we start here. This is where my box started, isn't it? So,
It's 4 pi.
what? This is a 2? Well, no, this is exactly in the middle between pi and 4 pi. So that's 2.5 pi. 2.5 pi. So what's the c? If I move it right, what's the c? It's minus 2.5 pi. So if I apply that, I'll get start at 2.5 pi and then finish at something.
Why is it minus 4 over 2?
Because you move it right, the c is
You
minus.
say the maximum point is just move right for the 4 pi.
Oh, sorry, that's actually a better idea. Sorry, thank you. That's a good idea. Yeah. No, yeah, I get the idea, yeah. So, Young Peng's idea here, if you look at a normal sign, where's the maximum? No, that's a very good idea. If you look at a normal sign, where's the first maximum?
0.
No, what value here?
9.
Yeah, pi over 2. Yeah? But where is it here? It's at 4 pi.
Oh, 6 twice.
So you moved from pi over 2 to 4 pi. So 4 pi minus pi over 2 is exactly the same thing I said a moment ago. 2.5 pi. 5 over 2. So that's 5 over 2 pi. And if I add 6 pi to that, what's that? 5 over 2 plus 6, please. What is it? 17?
17.
17 over 2 pi. Minus 4 to 4. So finally, what did I need to do at the end? To get to this graph. I had to rise it.
Yeah, the height.
How many units?
0.
So it is how many units for the d? 4. So I think I can make this graph by using the equation y equals 4 sine 3x minus, sorry, that should say over 2. 5 pi over 2 plus 4. I can expand and I get y equals 4 sine 3x minus 15 over 2 pi plus 4. 1 sec.
So it starts at 2, then it ends at 4. No, it starts at 4.
It starts at
4
5 over 2 pi. Starts here, wait, starts here and ends here.
for D.
Oh,
For D.
yeah, so that's 5 over 2 pi, 17 over 2 pi, 0 and 8.
Sir,
Yes,
can you please repeat why we choose 5 pi over 2?
1 second, yes.
It's the same thing, I think it's 6 over 8.
What is?
5 over 2 pi.
Because 4 minus.
Hang on, yeah.
Because if you subtract 4 pi minus pi over 2, that's 7 pi over 2.
Yeah.
And then you subtract pi over 2 again to get to the start.
Oh, sorry, it's the wrong subtraction. It's 4 pi. 4 pi minus pi over 2 is what?
7 pi over 2.
7 pi. Okay, thank you. And I said 5.
Yeah.
Okay, we'll fix that then. So that just means that should have been 7 over 2 pi.
Yeah.
And if can you add 6 pi to that, please?
That's 19 over 2 pi.
Okay, thank you. So I should have that in there instead. Thank you. So that's what. Yeah.
But still, I don't. That's.
Well, let me just write down the correct answer and then we'll get to that. 4 sine 3x minus 21 over 2 pi plus 4. Okay, go ahead.
Okay, why don't we subtract pi over 2 again to get back to the starting point? Isn't that where we're starting from? Isn't that what we're trying to find out?
I'm trying to figure out how far it's shifted to the right.
Yeah, but isn't that based on where the first point is?
Normally I look at where the first point is to where the first point becomes.
Yeah.
But you get the same answer if you look at where the maximum was compared to where it is. In fact, you can pick any point in the curve and look at where it's moved to. So you're thinking you have to move now again back to the start.
Yeah.
But it's a little trick, Young Peng's suggestion. You can pick one point on the sine curve and see where it moves to in the new sine curve. It's just, in class, I normally just pick the beginning of the sine curve. Yeah. Anyways, we can check if this is right because we can graph it and see if we get the correct graph. So, what is it here? Y equals 4...
Sine 3x minus 21 pi.
Y equals...
4 sine
Yeah.
3x minus 21 pi over 3.
Yeah.
Plus 4.
Alright. Window, tile vertically. Graph, window, tile vertically. Whoa. How far do I go on my x-axis in the picture? It goes up to roughly about 8 pi. 8 pi is roughly about 24. So let me just zoom out a little bit. To 25. Not too much. Alright, and the y goes up to 8, does it? Alright. Let's see. Ready? Yeah. Nice. I must have typed something wrong, because what the fudge is that? I mean, what is it? Try again. No, it's not right. It's very not right. Have I mistyped here?
Maybe try alphabet.
Hmm?
Maybe try another side.
Are you sure that's 7 over 2 though?
8
4 minus pi over 4 pi.
Use a calculator.
Is it 4? Is it 4 sine?
You can use the calculator.
But 8 pi minus pi over 2 is 7 pi.
So why did you choose 4 sine? 4 sine.
Oh, because earlier we said it has to be 4 because it's 8 units and it should be 2 units. There's something wrong with the C.
Why did he multiply that way?
Oh, because it expanded 3 times.
So it would be like minus 4?
Oh wait, hang on. No, that was the mistake. If it expands 3 times, it's not 3, it's 1 over 3. Yeah, we all forgot that.
Well, I thought.
Did you?
Oh, who's that?
What was that now?
You said given first.
No. Now let's zoom out. No,
Still wrong.
it's the C. Amjad, if you look at the graph, are you sure the maximum's at 4 pi? On the graph. It does say 4 pi for the maximum, yeah?
Yeah.
Check the markings.
He has it there. Oh, no, sit back down. No, sit back down. Sit down. Sit down. Sit down. I figured it out. Guys, look up. Listen, look up. The problem was right here. It's not 3, but it's 1 over 3. So when 1 over 3 multiplies in, that's 1 over 3. But 1 over 3 times that is 7 over 6. Oh, this is horrendously difficult. You can see why they took it out of the exam. So what did I say? 7 over 6?
Yes. How many marks was this?
How many marks for this, Amjad?
4.
I would skip that.
Good question. I just give it away.
Oh yeah, skip it. Not worth it.
Just keep using brackets.
I'm giving up on this, Amjad.
Oh, it's still wrong?
Yes.
Sir, just give it up.
Yeah.
It's not worth 4 marks.
No, it's not. No, Amjad, sit down. I don't want to look at you right now. You're ruining my life. What?
That's not 4 pi.
It's not 4 pi!
It is, but it's not exactly. You chose. How did you know that's 4 pi?
I think they mean 4 pi, but they're not clear. But you're right. Let's see.
Okay.
So it's 5, 4 pi over. What's the other value? Did they give you a range?
I think you should find what's the maximum point.
Ah. I've given up.
Publish.
Let's see what's the answer.
I've given up. I've screwed it up too much. I'd have to start it again.
I beat you.
Right, I'm starting again now. 'Cause you said that. No, so Amjad now, he's messed up. He's playing mind games with me. Right, just let me take some coffee first, alright?
I have a different question.
No, quiet. Right. Okay, look. Can I have everyone's full attention? Let's properly think about this because it'll be good for our general mathematical education. Alright? Good experience. So let's just, please stop me when you think something has gone a bit peculiar. So if we look at this graph to begin with, how big is it vertically? It's 8 units. And how big should it be? 2. From -1 to 1. Okay, so I think we can all agree that the A is definitely 4. Because you've made it 4 times bigger. Right? So we've figured out that part anyways. Now, we have a B here, and we have the X, and then we have the D. Let's look at the D next. So it goes from -4 to +4. But our graph goes from 0 to 8. So it's been raised 4 units. So that's definitely right. This graph goes from pi to 4 pi. That's 3 pi. That's half the period. This is one period, look. Starts at the bottom, goes up to the top, and then back down to the bottom. But they don't tell us this number. But we know half of it. From pi to 4 pi. So how big is that? 3 pi. But that's only half of it. So a full period, 6 pi, and it should be 2 pi. So how many times bigger is it? 3. And remember, this is reverse relationship, 1 over 3. So the easiest way to get the C, without messing about with the graphs, is to sub in a point that you clearly know on the graph. So if you look at this graph, which point are you 100% certain of?
0.
I would say this one. When you put in pi, you definitely get 0. So if I put that in, I have 0 equals 4 sine 1 over 3 pi plus c plus 4. Okay, bring the 4 to the left, becomes -4. Divide by 4, -1. Now, can someone just type in sine inverse of -1? What do you get? It's minus pi over 2?
Yeah, -5.
Minus pi over 2 equals pi over 3 plus c over 3. So, what is minus pi over 2 minus pi over 3, please? Minus pi over 2, minus pi over, minus 5, 6 pi, is it?
5 pi over 6.
No, don't let that battery go.
5 pi over 6.
How much time do I have? 20 seconds, alright. Stay calm.
Come on, 17. 15. No.
Is it on?
Crisis averted. Okay, so that's it. Is that correct? Minus pi over 2 minus pi over 3 is minus 5 pi over 6. That's equal to c over 3. So if I bring the 3 up, what will I get? Can you multiply that by 3? What do you get? Minus 5 pi over 2. So, I reckon the answer is y equals 4 sine 1 over 3 x minus 5 pi over 2 plus 4. Now, if this graph doesn't match up, I have given up.
Isn't this the first answer?
Yeah, the first thing.
No, it couldn't be.
Yeah, it was.
Are you sure?
That's one
Yeah.
thing.
5 over 2.
Did I make a mistake here?
Just the first step. What did you make for instead of 6?
Huh? It goes from 0 to 8, doesn't it?
Yeah.
I'm not mistaken there. It goes from 0 to 8, doesn't it?
Shouldn't be like 8 minus 2?
No. Don't do this to me. It's the lowest point is what? No, it's not. It goes below 2.
0.
No, but if you're counting only the boxes, then it's 2.
No. Forget about the boxes. Forget about the boxes. The lowest point here is
0.
0. Yeah? And the highest point? 8. So how big is that? 8 units. I can tell in your eyes you're thinking something you don't want to say. No! Y equals 4 sine 1 over 3 x minus 5 pi over 2
Don't we have to submit?
plus 4. No. I can just leave it like this, right?
That's
That,
the first answer that we got.
Yeah.
No, the first answer had 3x, not 1 over 3x.
yeah.
No.
It was
5
5 pi
pi.
over 2.
5 pi over 2.
Yep. Works. So it was just the 1
Don't.
over 3.
It was just the 1 over 3 that was screwed up. Now, you see, they took this question out. It was too difficult.
But why you did this?
You shouldn't give up.
Yeah.
Yeah, good. That's the lesson. Never give up.
And
Never give up. And never let Amjad beat you.
We would fail if we tried to solve it.
Yeah, well, that's why we do revision, so we can
Not
mess this all out before the exam. Yeah. Question? Yeah. Which one?
So it's 14, 15.
14, 15. Let me just write that down. Yeah, 14, 15.
Whoa. Version 1. Question number B6.
Integration.
It's, yeah, and it's very weird. And we have to find the angle.
You have to find the what?
The angle.
Oh. So they draw something, you have to find an angle in the picture.
No, it's one of the questions, but one of them is.
Do I need to do the rest of the question to do that part? Should I just do the whole B6? Yeah, okay. So do I need to have a graph in front of me? Yeah, okay. Can you open up this one, please? We'll have a look at this one. So, all right, hang on, let me just draw that. So you have this. There's a line here, and then there's a curve here. Looks like a quadratic, doesn't it? There's this point here. What's that? That's called M. And there's this point here, and that's N. And M is 2, 2, and N is 4, 4. And the quadratic is y equals x squared minus 5x plus 8. And that is probably a tangent, isn't it?
Yeah.
Yeah.
And there's a line and it should.
Yeah, and this is the normal then, probably.
And
Okay, so you can sit down and just read the parts out to me and we'll do them.
Okay.
Right, so when you're ready there, what's part A?
Okay, so part, so first of all, figure 4, which is not downstairs, shows the curve y is equal to x squared minus 5x.
Oh yeah, so we have all that info. So what are we asked for first?
Okay, first off, we're find the equation of the tangent line.
That's this.
halfway down.
That's this guy, yeah. Find the equation of the tangent line. Right, so we've seen this one before. What's our first step here? Derivative. So the derivative here is 2x minus 5. And what's the x to use? What's the x? You can see it on the graph. 2, because it's tangent at m and the x here is 2. So if I sub in 2, I'll get 4 minus 5, which is minus 1, which is good because it's sloping down. And I have y equals mx plus c. How do I get the c? Sub in 2, 2. So you have 2 equals minus 2 plus c. So c equals 4. How many marks for that?
3.
3, okay. Minus x plus 4. Right, part B.
The tangent meets the x-axis at point x. So your point x.
4. This meets
Tangent, yeah.
4. Yeah.
Okay. Find the coordinates of point x.
Ah, this is x. Is that what they want?
I think so.
Find where the tangent meets the x-axis.
Yeah.
Yeah, it meets it at 4, 0. Okay. Part C?
That was 1 mark.
Yeah.
Find the gradient of the line and hand. Which we already did.
Ah, what's this? No, we didn't.
Isn't it the slope?
No, but that was
Yeah, that was for the other one. Yeah, so what's the slope? What's the slope of MN?
1 over 101 minus 1 over.
Well, it was previously, the slope was minus 1. So now it's 1. Yeah, okay. D. Perpendicular.
Do we know that it is perpendicular?
No, it is, because they said it's a normal. They said it's a normal.
When did they say?
They didn't. Oh, I thought you said it was a normal. Okay. So MN.
Oh, you can just.
Oh yeah, we can calculate using. Yeah, no, I know. I thought they made MN a normal, but it's not a normal. It's not perpendicular.
Yeah, they don't see that.
Yeah, okay, but they give you M and N. Right. So what's M equal to? Is it? Oh, so then, okay. 4 minus 2 over. Okay. So I must have sensed that it was perpendicular.
Y 6.
Yeah? Okay, D.
What is the size of the angle MMX?
M, which one? MNX?
Basically angle M.
So a triangle.
No, you said MNX.
And angle N, which is N.
Oh,
Which is M.
NMX.
Yeah.
Yeah, okay, so you're right. That's this one here. Well, because of our discussion, we know what that angle is at N. Yeah, there's 90. Yes, correct.
Give a reason for your answer.
Yeah, but I think we might have to flesh it out a bit more than that. So, look, yeah, the slope of the tangent multiplied by the slope of MN equals minus 1 multiplied by 1, which equals minus 1. And you know if you multiply slopes and get minus 1, they're perpendicular.
Finally, find the area which is shaded between the curve and...
Right, so what is the two limits here for the integration? 2 and 4. And careful now, what are we integrating? If we look at the picture?
line over line curve.
Line minus curve, yeah.
Yeah.
But that kind of sucks because I don't think we have the equation of MN, do we?
We,
Yeah.
We don't have the
we have the points and we
have the slope.
Oh yeah, no, we can get it. I'm just saying it would have been nice if we already had it. How many marks for this?
For that question 8.
Ah, so they gave you an extra mark because you had to get the equation of MN.
Yeah.
But that's not such a big deal because you already have the slope.
Yeah, slope is,
So let's get the equation of MN first.
slope is 1 and sub in
Y equals 1x plus c. What point do we sub in?
n.
2, 2 or
N.
4, 4?
2, 2.
Yeah, well actually that makes the c very... Yeah, so y equals x. That's the equation. But you realise you could have seen that at the beginning because look, the point n is 2, 2 and the point n is 4, 4. So all the points on the line obey the equation y equals x. So you actually could have gotten that at the very, very beginning if you thought about it for a moment. Anyways, now that we have the line, what do we integrate? What minus what?
The line minus
The line minus the quadratic. And what's the quadratic?
x squared minus 5x plus 8.
Now, just realise, please, that you are getting 8 marks for that integration. So that's 2 to 4 minus x squared plus 6x plus 8 dx. Minus, correct, Jeff?
Yeah.
Oh, no, minus 8. Because I put the minus in. Yeah. Minus x cubed over 3 plus 3x squared minus 8x, and I put in 4 and 2. So calculator time. What's 4 cubed? 4 by 4, 64? 16, 50, 15, 40, 48 minus 32 minus 8 over 3 plus 12 minus 16. So whatever that works out as.
Are we to include something like that in the exam in terms of marking, or is that different?
Is what?
Just 8 marks.
It's a bit crazy, 8 marks. Like, what have I done? I've done 3 lines.
It's minus 16 over 3 the first one, and something
Minus 16 over 3?
yeah, for the first one.
Well, you would have to find y equals the line.
Ah, yeah, well, that wasn't much work. But you're right.
I'm also confused with one thing.
Yeah.
You scroll up a little bit.
Once I get the other number in.
Minus 20 over 3.
So 20 over 3, 4 over 3.
Can you explain why again minus y equals minus?
Yes. So you're happy that the equation of a line is y equals mx, true?
Yes.
Yes. And you're happy that the m is 1 because they asked us to calculate that earlier. So how do I get the c? I sub in a point. What point is on my graph?
M.
You have 2, 2, or you could use 4, 4. So if you sub in 2, 2, yeah, okay. Yes. Now, what was your question?
Exact same thing.
Good. You're happy with the answer as well?
Yeah.
Okay.
Sounds confused how you got y equals x.
What's that trapezoid rule?
That's in semester 2. The syllabus has changed, obviously. So originally they had the trapezoid rule in semester 1, but it's not anymore. In fact, I don't even know if the science students do it. I think just the engineers do. Yeah. Yes.
There's another question.
All right, well, let's just give someone else a chance. Didn't you just ask me this one?
Yeah, no, but it's
Oh, another part of this.
No, just one second. Do we have to know anything about matrix?
No, that's removed. You know the probability we're doing? That replaced the matrix in the old exams. Yeah.
I have a question for 16, 17.
Thank you. More recent is better, yes. Scrolling down.
What's the question number of this one?
It's B6.
15, 16.
Right. Wait. 16, 17?
16, 17, version 1. A10.
Okay.
The 16, 17 file is not about
No, it's there.
15, 16, 17. Where's 16, 17?
Look. Leave me alone, please. He says he has 16, 17 version 1. I'm going to believe him. I don't think he made up an exam, typed it up, and is pretending that this is an exam. So 16, 17 version 1.
Yeah, it's y equal radical 1 minus cos x.
Yeah. Like this?
It's rotated about the x-axis between x.
Hang on a second. Are you looking at the final semester 2 exam?
Oh, am I?
There is no 16, 17 file.
Are you in the wrong folder?
Maybe. I don't know.
No, I know what's happened now.
This is geometrical
You
convolution.
wanted to map
Yes.
It's not supposed to.
Can we solve a question about sector of circle?
That,
Hey, 16, 17.
Does someone does?
Okay.
do you remember doing that with
That's
me?
semester, it says end of semester 1. Yeah.
It's not on the current syllabus.
Why doesn't this show?
So how should we solve this one?
Semester 2.
Yeah, never mind, sir.
15, 16,
Yeah.
17.
Yeah, no. I believe you now. When he said the question, I realised his mistake.
So
So sit down.
16,
It's end
17
of-
is gone,
it's
or
this.
it's not here?
16, 17.
I just opened it.
NCUK didn't write the exam that year, but which I think I have something
Yeah.
for 16, 17.
I just opened it. End of
Yeah, but what page are you on? Are you
What
on?
math course one?
NCUK
Yeah,
semester 1.
have a look at Maths for Science. The folder might be in there.
But wouldn't that be for the full semester?
No, no,
just-
no.
No, there's both semester 1 and 2 in that page.
You can print what it is. So that's off syllabus.
What's the next question? Next question.
Oh,
Yes.
16, 17, same one, but A3,
Yeah, okay.
4K plus 3.
Hold on. A3, 16, 17, right?
Yeah.
Yep.
Option 1. 4K plus 3.
Yeah.
6K minus 2.
Ah, 4K
Yeah,
plus
this
3.
is like a consecutive term in arithmetic.
Oh, comma.
Yeah, comma. 6K minus 2
Yeah.
and 7K minus 1 are 3 consecutive terms of an arithmetic progression.
Find K.
Find K.
Right, so we've seen this one in class. You're told that these 3 terms form an AP. So what's special about the relationship between these 3 terms if they form an AP? Yeah, the same difference. So the difference here is the same as the difference here. So that means 6K minus 2 minus 4K plus 3 should be the same as 7K minus 1 minus 6K minus 2. So that's 10K plus 1. Oh, sorry, thank you. 2K plus 1
Plus 1.
minus 5.
Minus 5.
Wait, K plus 1. So that means K equals 6. If I put 6 in, what do I get? 4 times 6?
24.
24 plus 3? 27. 6 times 6 is 36 minus 2. 34. 7 times 6 is 42 minus 1 is 41. Are they arithmetic? What's the difference between this and this?
7.
7. And here? 7. So yeah, they are arithmetic. How many marks?
4. 4 marks. This is an A section.
Yes. Yeah. Next. That's it. Done. I didn't get many study timetables from people yesterday. Disappointing. So you should have done like an hour of revision yesterday. So that means you should have some kind of questions, unless you did an hour of revision and had no questions.
I did the worksheet.
Possible.
Did the worksheet.
It was like day 1.
No, I didn't.
I have a question,
Yes.
but it's not from NCUK.
It's from the workbook.
No,
Go on.
it's from an.
Where's it from?
It's from a 12 class paper.
Ah, no, sit down.
Can you just take a
No,
look at it?
no. Only workbook or exam.
It's the same thing.
I tell you, if we got to a point where we did all the workbook and all the exam, then we can look at external stuff.
Yeah, okay. It's just
I have a question.
Yes. Sit, please. I can't see Amjad.
Sorry.
Oh no, actually stand. Right. Go on, Amjad. Question.
Simplify.
Wait, which year is this?
Uh,
It says it on the bottom of each page if you look.
Yeah.
In the footer.
Wait, page next to page number. On the same line. Page number.
Number 16, 17.
Yeah.
A5.
What version?
Where is 1?
Okay. A5. What's the question?
Simplify x cubic. Radical square root of 3.
Square root of what?
No, 3. Radical 3.
You mean cube root?
You mean cube root? Cube root. Yeah.
Okay. X
Yeah.
power 8.
Yeah.
X power 4.
Yeah.
Over x power 4.
Yeah.
All power 6.
The whole thing power 6.
No.
In the brackets here. Power 6.
And there's x cubic outside.
Like here.
No, outside.
All right, like here.
Yeah.
Yeah. Simplify this.
I can't find the question.
Into x.
Where's the finding this question?
No.
Where is it?
Where is it?
A5
If-
is a log question.
Yeah, it's a log. Look right there.
Yeah,
Are you
it's
looking
not
at-
question.
Are you looking at 16, 17?
Yeah, end of semester.
Yeah.
Oh, it's 50.
It's not that hard, by the way.
15, 16. Okay.
And express your answer in x power a.
Okay.
Where a is an integer.
Right. Shh. Let's have a look. Just ask me this question. Look at it, please. Or are you just asking me this to keep me busy while you have a chit chat? Is it? Right. So this question is all about using the rules of powers, and it's quite flexible in the order you can proceed. So perhaps I'll deal with the cube root first. What power is a cube root? 1 over 3. So you'll have x8, x4, x4. And then this is 1 over 3. But you already have a 6. So what happens to the powers? 2.
Shouldn't you expand?
Yeah, no, I'll do the expanded next. So here, this is x4 and x4. So they cancel.
Would it matter what order you
No, it doesn't. This is x8. Right, so what's next now?
multiply?
Multiply. Good. So what do you get here?
16.
16. And here? 3. Total? 19.
They said to show the answer in x power 8.
5 marks.
X power 8?
Yeah. What did they say show the answer in x power 8? 8, 8.
Hey, yeah.
8, oh.
X power 8. Yeah, okay.
That's a lot of 5.
Yeah. Whoever wrote that was being generous. That's my version of the exam I wrote. Are all the section A questions the same marks? Same number of marks?
It's all 5, 5.
Yeah, that's my one I wrote. Yeah. I made all the A questions 5 marks. So I don't know why I put x4 and x4. It did, didn't it? Yeah. Okay. Next one now. Similar to this? Yeah. Okay. Can I scroll down? Right. Go for it.
It's a fraction.
Shh. Guys, I can't hear her. Guys, I can't hear her. Go on.
It's a fraction.
Yeah.
On the numerator, it's x power 0.7
Yeah.
times x power 1.2
Yeah.
over square root x power 0.8
Yeah.
equals 1.331.
And you have to find x. Yeah, okay. Can we all look at this carefully? Because this is a common enough question. I've seen it a couple of times in the exam. So let's take the numerator first. We multiply, so we add the powers. So that would be 1.9. And what power is square root? A half. So that's, yeah, so that's 0.4. Now, what should I do next? Minus them. So that would be x power 1.5 equals 1.331.
There are negative sign.
Is there a negative?
No, that's
No, that's fine.
mistake.
Everything's right so far? Yeah. Now, here's the nice thing to finish this off. No logs, not necessary. What you can do is put power 2 over 3 on both sides. Because 1.5 times 2 over 3 is 1. So x power 1 is x. So x is 1.331 to the power of 2/3. Yeah. And okay, so what's that, please? Yeah. Yep. Because it's not always obvious what power to use. So in a moment I'll just go back to this step then and use the logs.
When you put 1.5, why did you multiply the power
You multiply powers when they're together.
Yeah, when it's power, bracket power, that's
Yeah,
multiplied.
yeah, yeah.
But it's added when it's no brackets,
Huh?
right?
What do you mean?
So for example, like in the numerator, you add
You add them, correct. Because you have two x's.
Yeah.
Yeah.
So when you wanted to take out the square root,
Yeah.
why did you multiply, not add?
Because that's the rule. There's a double power here. There's a power 0.8 and a power 0.5.
Oh, it's like so like x power 0.8 bracket.
Yeah, yeah, yeah. Now, Sevi, you were asking me to continue from here using logs. So if you can all look, if I was to use logs, what I would do is put a log on the left and a log on the right. But one of the rules of logs lets me take that power down in front. No, actually, I don't think logs would be great here because you're looking for x and you'll change it into log x. You can't. Okay, no, you can use logs, but it's much worse than you're thinking. It might be easier. It's harder. So if I put log on both sides, so if I have x power 1.5 equals 1.331. Okay, watch what happens. Log here, log here. Bring the 1.5 down. So you get log x equals log 1.331 over log, over 1.5. But you don't want log x. What do you want? X. How do you cancel a log? With an e. So now you have to put an e on both sides. So you get x equals e power log of 1.331 over 1.5, which equals 1.21. So it's not easier to use logs here, actually. It's harder.
I think it's easier.
You're just saying that because I said it's harder. That's the only reason.
I think it's easier because it's harder to figure out what to use to do.
Okay, fine. So let me show you an easier way. X power 1.5 equals, what was it? 1.331. Now, watch. Shh. Don't, please. You. Watch. X squared equals 9. X equals square root 9. Okay? X cubed equals 9. So X equals cube root 9. X power 1.5 equals 1.331. So X equals 1.5 root of 1.331. Yeah. Now type that in on the calculator and you will get 1.21.
We're doing coefficient question.
Yeah.
Actually, there's another one.
I'm going to do great on this exam because I'm doing so many practice questions. Like, I think I'm going to get 100. Is it possible?
No, this one's actually hard. 16, 17, division 1.
Question?
A7.
Okay, just give me 1 minute. I need a bit of a
Yeah.
breather. If you can open this one next, we'll have a look at it. Okay, I think I'm ready now, Mo. Go ahead.
The curve C has the equation y equals 1 over x minus log x. Find the equation of the normal to curve C when x is equal to 1.
When x is equal to
1.
When x is 1, what's y? Y is 1. Because it's 1 over 1 minus log 1.
But they say the equation of the normal to the curve C.
I know, but I'm still figuring out the x and the y before I start. So the question is, find the normal at 1, 1.
No, at 1. I only give you x.
Yeah, I know, but you have a formula for y if you know x.
Yes.
Yeah, okay, so find the equation of the normal at 1, 1. Yes, so the derivative here is minus 1 over x squared. Bring down the power, reduce the power by 1. Minus 1 over x. If you put in 1, you get minus 2 here. But you want the normal, so that's 1 over 2. So you have y equals 1 over 2x plus c. So the c has to be a half.
yeah. We did this.
No, we just did one like it, I think.
Did you?
How many marks?
5.
5. Nice. Nice.
Same paper.
Wait. Same paper.
A4.
A4 next.
In the expansion of
8. Okay, A4.
in the expansion of
Yes.
3 plus px to the power of 6.
Yeah.
Where p cannot equal to 0, the coefficient of the x squared term is the same as the coefficient of the x cubed term.
Right, find P.
Find p.
So the coefficient of the x squared term is 6c2, 3p, and that's a 2, and that's a 4. That's the same as the coefficient of the cubic term, 6c3, p cubed, 3 power 3. Right, well, let's clean this up a little bit. So you can divide by p squared. So you get 6c2, okay, 6c2. You can cancel that with that. And you can cancel that with that. So you're left with 6c2 times 3 over 6c3 is the answer. Six C2 divided by 6C3 times 3. P is 9 over 4. How many marks?
5.
I think it says supersonic speed in 1 hour.
This section A. Yeah.
And then
It's kind of a lot, 5 marks, because it's done in 2 lines.
for you.
If you were doing your revision with the timetable like I suggested. Yes? Again? Yeah, okay. Alright, so let's have a look at this again.
You just did it a quicker way. The way we used to do it is you expanded
What do you mean the way we used to do it? Where?
earlier on we didn't do it like this.
Yeah.
We didn't cancel like that.
Pascal rule.
Yeah.
Are you sure?
Yeah. We were
No matter.
We used to like expand and then minus and then find.
Oh my goodness. Okay, fine. I'll make it more similar to
No,
that.
I understand. But
Okay, fine.
I'm saying
Right.
that's why people are confused.
We'll go a little bit slower here. Let's have a look at this. Okay. So, first we'll expand. Now, we'll skip the first few terms. We don't need to begin considering terms until we get to the squared and the cubic, because the question gives us information about the squared and the cubed. So we'll skip the first and we'll go on until we get to the square. So you know when you expand, it looks like this. You have a C with a number and a number. Then you have a 3. And then you have a px, and they all have powers. Now, if I'm looking at the squared term, what's the power here? 2. And therefore, what must this power be? Why? They add up to 6. What's this power number here? 6. And down here? 2 or 4, you can use either. Right, that's the square term. Agreed? Right, we continue until we get to the cubic term in the expansion, which will be 6c something, 3 with a something, and a px with a something. Right, what power goes here? 3. And here? 3. And here 3. Now, you're looking at the coefficient. What does coefficient mean? The number in front of the x. So you actually don't care about the x. So you can say 6c2, 3 power 4, p squared equals 6c3, 3 cubed, p cubed. Because the question said the x squared and the x cubed coefficient are the same. Right? Now, let's simplify. What's in common? Is there a p on both sides?
Yes.
Yeah. So what I'll do is I'll divide both sides by p squared. That cancels that. And p cubed over p squared? So just p here. What else can I divide by? 3 cubed. I put a 3 cubed on both sides now. 3 cubed and 3 cubed? Cancelled. 3 power 4 over 3 cubed?
3.
Just 3. So that and that is gone. So remember, I'm looking for P. What's the last thing to divide by? 6C3 and 6C3. So here, cancel, cancel. So what's left on the right? Only P. And what do I have on the left? I have 6C2 over 6C3, and I also have a 3 on the top still. So I multiply this by 3, and that's the P, which, as I said, was 9 over 4.
How's that any different to the third?
There is no difference, but
What if they say that the second coefficient is 10 times larger than the third?
yeah, if they said the x squared is 10 times bigger than the x cubed, then I need to put a 10 in here somewhere. On the left or the right? Correct. And you realise this is, apart from the dot, 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 I kind of wrote the same thing.
Yeah.
Okay. How many marks did we say? 5. Yes.
What's the period of graph?
The length from the start to the end is usually 2 pi. Yeah? Yeah?
Not amplitude. You say?
No. Amplitude is the distance from the center to the top. It's the A.
The max.
Kind of. It's the A in the formula. The big A. Yeah? You must be looking at old exams.
No.
How recent was that one?
14, 15.
That was the previous exam writer, so. Okay, what's next now?
Then it comes both the area and the perimeter of the right triangle is 30. What is it?
Hang on. You're just giving me.
Yeah, that's in the book.
In the workbook.
Yeah.
We're jumping to the workbook now. Okay, well, just before we do that, any more exam questions to do? Okay. What page is that in the workbook? 58, what number?
11.
Right, go read it.
Both the area and the perimeter of the right triangle is 30.
Yeah. Page 58, question 11. I tell you, both the area and the perimeter of a right angled triangle is 30. Find find x, y, z, is it? Right. X, Y, Z. What's the perimeter? X plus Y plus Z. And what do I say it's equal to? 30. The area is 30. What's the formula for the area here? A half by X by Y. That should equal 30. Or you could say X by Y equals 60. And lastly, because it's a right-angled triangle, what do I know about the relationship between X, Y, Z? Equals Z squared. So, how many equations? 3. How many unknowns? 3. So, it should be solvable. Do you want me to continue or not? Okay. You had trouble forming the equations. Yeah. You forgot about Pythagoras. Our buddy Pythagoras. Okay, what's next now? I'm concerned that you guys aren't doing enough and I'm doing too much. Yeah? Yes. Thank you. Okay.
We don't need to know show that area of this triangle as like proving.
There's no proofs on the exam. No. What's next now?
When can I show this exam question? Just
No, don't be distracted with this.
So can I come to you to show you something?
Oh. Don't you think I've done enough for you today?
It's just like the third. I know how to solve the first two parts. Just the third part.
Which question is this?
It's a probability question.
Fine, we'll do it together. Which paper?
No, it's 16, 17 version 1 again.
Okay, 16, 17 version 1 question
B2.
B2 part
A.
A. Right, let's read the info.
A girl plays 2 games of squash.
Yeah.
The probability that she wins each game is shown in the tree diagram below.
Okay, so it starts off with she could win, lose, win, lose, win, lose. And what do you know? Do you know this one?
Yeah, 0.75.
Okay, do you know the lose? Well, 0.25.
Yeah.
Yeah. Do you know this?
Q.
Okay.
Is Q, and the other one is R.
Yep.
0.4.
Yeah.
0.6.
Okay, good, good.
So first they wanted P, which is 0.25.
Okay, fine.
The probability that she wins both games is 0.6. Find Q. And
Okay, so the probability she wins both games is 0.75 times Q, and you're told that that's equal to.
0.6.
So can you find Q?
Yeah.
Of course you can. What is it?
0.8.
Okay, and so then what's R?
0.2.
0.2.
So find the probability that she wins exactly one game.
Right, she wins exactly one game. So that means she wins and loses, or loses and wins. So there's how many? There's 2 paths. So it's this or this. So you have to multiply. The first one is 0.75 times 0.2 or 0.25 times 0.4.
Sum up.
And there you go. Was that it?
Yeah.
Oh, good.
Just didn't know the third.
Good. Good. Ah. Yes, okay. What's next? Exactly means don't give a decimal answer. Leave your answer with the square roots and everything. Right, what else now?
If they say don't show every step.
Yeah.
No matter what, you should show it without these.
No, that's not what that necessarily means. It just, they're basically saying, show me the key steps and don't skip any steps. In other words, usually that question, show every step, means they really want to see the steps where you had to use a log or power rule. Do you know what I mean? So, like, imagine step 1 was you had to say log x times y is log x plus log y. They want to see that.
Oh, they want you to see x plus.
Not just make it clear that you've used that rule, but imagine that there was one step where you had to have like 2 times 3 times 6. They don't care if they don't see you multiplying that. You know what I mean? Like, it means that show us the steps where you had to use a rule.
Okay.
That's essentially their point. Right. What's next now? Next.
If you want to continue B2, it's up to you.
Oh no! No.
It's a triangle.
No,
it's an
it's
area
up to
question.
you because like I said, I think I can get 100 in this test. I don't feel I need to practice more, so it's what you need to see. Need to see.
Well, this is an area question. So
Do you need to see it, or you just would like to see it?
I know how to solve it, but like.
So then why are you asking for it?
I'm not sure.
No, I believe in you. You said you know how to solve it, don't you?
Yeah.
Yeah, so I believe in you. Okay. What's next now? Silence is bad. Silence means you're not doing enough revision. Or you're geniuses.
C.
Yes.
down below.
Which one? Yes? Did you not put up your hand? Yeah, which one?
It's from the 17.
17, 18. Okie dokie. 17, 18, which version?
1.
And which question?
A6.
Right, let's have a look at that. Version 1A6. Ah, the trig equation. Yeah. Hey, 5 marks is all right. Let's see. Cos 2 theta equals minus 0.766. Solve. Right. How, Sevi, look up. How many solutions does this have? 4. How did you get 4? 2. Yeah. Should have 4 solutions. Right, what's the first step here? Cos inverse. In degrees, what is the cos inverse of this, please? 100?
39.
Point.
996. Which
Ah, so 140 then. Okay. Now, how do you get the second answer for cos? 360 minus the first. So that is
220.
220, isn't it? Now, how do you get the 2 extra answers here? Plus 360 to the first 2. So that, is that 500?
Yes.
500? Then 580.
Divided by 2.
And finally, we divide by 2. And there you go. 5 marks. That's a nice one, yeah. That's a nice one. Yes, I'm good. What? What are you thinking? I don't know. Why are you thinking something? What?
Ooh, I have a question.
You're tired. Is watching me do all this work tiring to you?
I have a 3-part question.
From which paper?
13, 14.
The worst thing that will still happen.
Sir, can you tell me if I'm right or not? I'm not sure.
I probably not.
Can I come up?
Yeah, come on.
Stephen, can we stop and have a break?
Well, we're going to finish the class in 6 minutes.
Okay, so for this,
The class is over in 6 minutes. Yeah. Yeah.
Let's go now.
No, because I need to do the attendance, and this guy has a question. So, just let me see if you're able to do it. Show me the question.
so it's this one.
I think Amjad can help you with that.
Okay, so
You see if you can. I need
No,
to
I understand the,
yeah.
the third part, but the third part,
Find
don't
the
you-
shortest
don't
distance.
you have, yeah, don't you have to find the height anyways? Because, but,
But you could find the height from the area.
yeah,
Half the base by the height.
yeah, but you find it before. Why are they asking you third? On the third question. Like you,
Well, it's only one
you have
mark.
to find it in the second question.
Do you? Oh, you found the base to get the.
Yeah.
Well, you see, you could do it without finding the base.
Okay.
So, in the approach you took, it means you got that mark for free.
But it's not an isosceles triangle, so does it matter?
What base did you find?
No, the BA and AC are not equal,
Correct.
so it's not an isosceles triangle.
Right.
So BC, I can't go half of it, right? It's both sides on.
Well, you can.
You can.
Area is half the base by the height. Now, the height is the perpendicular height, not the
Yeah.
side.
Yeah.
Did you find the perpendicular height?
No.
Ah, okay. So, yeah, you need to work it out. Anyways, I'm just look at it.
I don't work for free.
For this afternoon is so long.
No, hang on. Sit down. No, sit down. I need to get something.